Alright, this section's over exponential functions and equations, and this particular function here is, of course, an exponential function because the variable is up in the exponent. I've got something written over here. This is just to kind of remind you that a number raised to the 0 power is equal to 1. So I thought I would just throw that in there. But in the previous section we talked about inverse functions, and so in the next section we're going to talk about how do you find the inverse of this function. How do we find the inverse of a function whose exponent is or whose variable is up in the exponent? But first we're going to just graph these. And of course, you know, when we learn how to graph, we just kind of do a table here. Now I'm going to start with 0 and then 1 and 2, and so this is going to be my x, and then this will be 2 to the x column over here. So when we plug 0 in up here, 2 to the 0, we get 1, and then 2 to the first power we get 2, and 2 to the second power, right, we're taking this 2 and plugging it over here, we get 4. So we call this exponential growth. Right, this is sometimes known as exponential growth. The function is increasing exponentially, so you might hear that also. Right, and so we can go on and on forever like that. And of course, if we had to graph this thing out, we would start with, let's change colors here. We would start with plugging 0 in, we get 1. Right, and we'll say that this is 1, 2, and we'll do 3, even though it's not written right there. We plugged 1 in and we got 2 out. Okay, plugging 2 in, we get 4 out, and then plugging 3 in, 2 to the third is 2 times 2 is 4 times 2 is 8. So anyways, so we get something like, you know, we get a graph that looks something like that. And actually I do have these graphed out. Okay, so let's just actually go take a look at what this graph looks like. So as you can see here, this is the graph. Of course, you know, I plotted this point here, and then this point. Let's see, this is 1, 2, 3, 4. Yeah, plotted this point, and then this point here, and then so on. Okay, and yes, it does have. We can plug negative numbers into this and get this part of the graph also. All right. Okay, so we graphed. I declare the board there. F of x is equal to 2 raised to the x. Alright, what happens when this number is between 0 and 1? For example, we'll call this g of x, give it a different name, and we'll say a half raised to the x power. Well, this can actually be rewritten as 1 to the x over 2 to the x. Okay, this is still an exponential function here. 1 raised to the x is just 1. So no matter what you plug in for x here, okay, you're going to always get 1 out. And then this is 2 to the x. So what happens when x gets larger and larger? For example, if we do a table here, so this is my x's, and this is 1 over 2 to the x goes here. So if I were to plug, for example, 0 into this, 2 to the 0 is 1. So 1 over 2 to the 0, you would have 1 over 1, which is just 1. And then if I were to plug 1 in, you'd have 1 over 2 to the 1, which then becomes a half. So you see what's happening? The number's getting smaller and smaller. And if we plugged a 2 in, we'd have 2, and we get 1/4. So if we take a look at this, what's actually happening here is the graph is going to be decreasing like this. Okay, it's going to be decreasing, and of course, as x gets larger and larger and larger, it will never really approach 0 unless you're considering going to infinity, but that's calculus class, and I'll leave that for calculus. So when we're talking about limits. But anyway, but it gets closer and closer to the x-axis as x gets larger and larger going outward. So let's take a look at that graph. Okay, so this was 2 to the raised to the x, and this red line right here is a half raised to the x. We can see that it's getting closer and closer as x gets larger and larger. And look, there's some Okay. Let's look at if we had, well, actually, let's go back to f of x is equal to 2 raised to the x. And I just want to sketch this graph out real quick, which it looks something like that. Now, what if, how do we get this graph to reflect about the x-axis? Well, for example, you would take 2, let's say, and you would plug it in to here, and you'd get 2 squared is 4, right? But down here, if you were to plug it into this function, you would get -4. All right. So all we have to do, and I'm going to call this one g of x, is throw a negative out in the front. So we would just throw a negative out in the front of this function here, and that would cause the graph to become reflected about the x-axis. All right. So what happens if our graph did this and we wanted it to do this? Right, be reflected about the x-axis. Well, we'll say that f of x is equal to a half, or I'm sorry, yeah, a half x. Should be an x there. Okay. To get this to reflect about the x-axis, we'll call this one g of x. You would throw a negative out in front. So you see, throwing a negative out in the front causes the graph to reflect back the x-axis here. All right. Let's actually look at some computer-generated graphs. All right, this particular graph here is a half raised to the x, so it's decreasing. As x increases, it decreases. Now, to get this to reflect about the x-axis, we would throw a negative out in the front of it, right? And as you can see, this is just a reflection, okay, about the x-axis here, reflection about the x-axis. Easy enough. All right. Okay, I want to revisit an earlier topic, and that was inverse functions. And the reason why we even talked about inverse functions. So this is, we'll say this is 2 to the x right here. All right. And we can graph what the inverse is going to look like. Now remember, this line right here, this is y is equal to x, and I'm doing a terrible job of that, but this dotted line is y to the x. Now remember, and I'm going to do this in a different color, the inverse function, so this would be f inverse. And we don't know what this is, but we know that it looks something like this. Well, actually, this is not a dotted line, and I don't think I'm doing a very good job here of this. But remember that it's a reflection about this y is equal to x right here. Okay, the inverse function is a reflection about the y is equal to x. So at least we have an idea of what this inverse looks like. All right. So I just wanted to throw that in, that little extra in on us, since we covered inverse functions in the previous section, or just kind of a summary of what an inverse function is. I'm going to, let's see, actually, you know what, let's look at this part of it, the equations here, and go back to exponential functions. Alright, I want to talk about real quick here about exponential equations. Okay, and for example, if I had 8 is equal to 2 to the x, and we wanted to solve for x in this problem, well, I want you to think about this. What number could we possibly plug in for x that would give us 8? Well, what about 3, right? Because 2 to the third is 2 times 2 times 2, which is 8. So x is equal. Alright, and let's look at another one here. So I just kind of wanted to go over how to solve exponential equations, because in some later sections we're going to be working with some pretty complicated equations, and it's not going to be easy to solve for x like we're doing here. Right? We can just kind of look at these and tell what x is. So in this particular one here, we'd probably want to let x be what? 2? Because that should be a 3 squared is equal to 9, right? 3 times 3 is 9. Okay. Let's look at a little bit more difficult one. What about if I had 1/4 is equal to 2 raised to the x? Now what I'm going to do here is I'm going to take this 4 and bring it up into the numerator. Alright. And now I'm going to take this 4 and write it as 2 squared. But remember, it's all raised to the -1. So these are kind of like a typical problem you'd see on a test here, and this is the way they'd want you to do it. Now I'm going to take these exponents and multiply them, so you have 2 times -1 is -2. And so therefore x has to be equal to -2. Alright? So we had to manipulate this left hand side and get these bases to look the same. That was the key. Okay? So let's look at another one on that. Alright. I don't know. Let's see. What about this one here? Maybe I should let you try to work this one out. Right. So I'm going to rewrite this base. This is 4 to the -1 is equal to 8 raised to the x. Now let's think about this for a second. We know that 8 is what? 2 times 2 times 2. So if this was written as 2 squared, let's see, this would be 4, right? Let's see, 4 times 2. We're getting close here, I think. Let me rewrite this down here. Wait a minute. 2 cubed. 2 cubed is 8. Isn't that what I got written there? So if I were to do this, 2 cubed, so you got to kind of play around with this stuff, raised to the x, and then this was 2 squared, raised to the -1, and so we'd have 2 to the -2 is equal to 2 to the 3x. There we go. Alright, we had to work this one out. This is a tough one here. So then both of our bases are the same, and so we set our exponents equal to each other and solve for x in this problem. So we'd have multiplying both sides by 1/3. Alright, and we'd end up with x is equal to -2/3. Now we can always check this out by writing, what was it? It was 8 raised to the be -2/3. That has got to be equal to 1/4. And if it's not, we did something wrong. Okay? But my guess is that it is correct. Alright? We can actually rewrite this as 1/8 to the 2/3. Now 8 to the 2/3. This is can be rewritten as 8 raised to the 1/3, and it's all squared, but 8 to the 1/3 is going to be 2, and 2 squared is 4, and so as you can see here, we'd end up having 1/4. Right, I shouldn't write a multiplication down, I should write an equal sign there. Alright, I'm going to work a couple more of these exponential equations, and then I think I'll quit on this section on exponential functions and equations. So let's see, we've got 8 is equal to 4 raised to the x over 3. So the idea is we want to get both these numbers here to be the same. And the way I'm going to do this one is I'm going to say, let's see, 2 squared raised to the x over 3, and then this one here will be 2 to the third is 8. And so now we're going to have both the same base, and so I'm going to rewrite this 2 to the third, and then we multiply exponents, so we have 2 times, or 2 raised to the 2/3 x. Well, now that we have both of our bases the same, we set our exponents equal to each other and simply solve for x. Multiplying both sides by 3, you get 9. 2x, then multiplying both sides by a half, and we end up with 9 halves is equal to x. So there we have solved for x, and what you can do is go ahead and test that out. Take that and plug it in to right here, and you should see that this side should equal 8. Alright. Okay. Try to work as many as I can here. Alright, here we go. We've got 1 over 81 is equal to 27 to the x. So we know that 9 times 9 is 81. We know that 9 times 3 is 27. So we know 9's involved in this whole thing here, right? So I'm going to rewrite this as 81 to the negative 1, taking this up into the numerator and just rewriting everything here. Alright, let's look at this 27. We know that 3 to the third power is 27. Okay? And if we look at 81, we know that 9 times 9 is 81, but we also know that 3 times 3 is 9, and 3 times 3 is 9. So this becomes 3 to the fourth power. So we're going to be working with the bases of 3 here. So we have 3 to the fourth power. Remember, that's all raised to the minus 1. And then this one here, we're going to have 3 to the third power, and it's raised to the x. Okay? And so now we're just going to multiply our exponents. So that's going to be a negative 4. And this will be 3 raised to the 3 times x. So now that our bases are the same, we set our exponents equal to each other and solve for x. So this becomes multiplying both sides by 1/3. And 1/3 times 3x. And so we have x is equal to negative 4/3. Negative 4/3. Alright, and of course you can take that and plug it in up here to see if that's going to be 1 over 81. Right. And because this is a negative, we can take this now and rewrite it with a positive exponent. And of course, this can be rewritten as 3 roots of 27, and the whole thing raised to the fourth power. Now, 3 roots of 27 is just 3. Whoops, I about made a mistake here. There's a 1 up here in the numerator. Okay, this is in the denominator. So this becomes 1 over, this is a 3 down here, and 3 to the fourth, remember, is 81. So there you go. The right hand side is equal to the left hand side, and we solved for x. And I'm going to finish this section on exponential functions and equations, and once you get it down, move on to the next section, and before you know it, we're going to be doing college algebra.